The deeper we look into the ancient world, the more it begins to feel less like a distant, primitive past and more like a fragmented memory of achievements we no longer fully understand. These discoveries are not myths or legends, they are physical objects, studied by scientists, displayed in museums, and accessible to anyone willing to see them. Yet, despite their visibility, they continue to challenge the frameworks through which history is usually taught. Beneath the desert plateau of Saqqara, the vast underground complex of the Serapeum of Saqqara remains one of the most striking examples. The granite boxes housed there are not just large, they are engineered with a level of precision that raises difficult questions about the tools and methods available at the time. Granite, with its extreme hardness, is notoriously difficult to shape even with modern equipment. Yet the internal surfaces of these boxes are polished to near perfection, with flatness and alignment that rival industrial standards. Transporting such massive objects over long distances is itself a monumental challenge, but positioning them within narrow underground corridors adds another layer of complexity. The fact that one unfinished box remains in a passageway, as if abandoned mid-process, only deepens the mystery, suggesting that whatever knowledge or technique was used may have been lost suddenly or deliberately. This idea of lost knowledge becomes even more compelling when we consider the Antikythera mechanism, discovered near the island of Antikythera. What makes this device so extraordinary is not just its age, but its conceptual sophistication. It represents a fusion of astronomy, mathematics, and mechanical engineering that seems out of place in its historical context. The mechanism's ability to model celestial cycles with such precision implies not only theoretical understanding but also the practical ability to translate that knowledge into a physical system of gears and dials. This was not a crude approximation, it was a highly refined instrument, complete with inscriptions that functioned as a user manual. Some researchers believe it may have been part of a broader tradition of complex devices that have simply not survived the passage of time. If that is the case, then what we see today may be just a single surviving fragment of a much larger technological landscape that has otherwise vanished. In India, the enduring presence of the Iron Pillar of Delhi continues to intrigue metallurgists and historians alike. Located within the Qutb Minar complex, this structure is often cited as evidence of ancient mastery over materials. The pillar's resistance to corrosion is not the result of a protective coating applied after its creation, but rather an inherent property of the metal itself. This suggests that its makers had a deep, empirical understanding of how different, such as phosphorus, interact within iron to produce long-term stability. The forging process, which likely involved repeated heating and hammering, would have required careful control to maintain this composition. What is particularly fascinating is that this knowledge was not recorded in a way that allowed it to be widely transmitted or preserved. Instead, it appears to have been localized, possibly even guarded, and eventually faded from common use. A similar sense of advanced yet isolated knowledge can be seen in the Lycurgus cup, a masterpiece of Roman craftsmanship now housed in the British Museum. At first glance, it appears to be an intricately carved glass vessel, but its true uniqueness emerges when it interacts with light. The dramatic color shift, from green and reflected light to red and transmitted light, is not merely decorative, it is the result of precise manipulation at the nanoscale. The inclusion of gold and silver particles, each carefully proportioned and distributed, creates an optical effect that modern scientists only began to understand in the context of nanotechnology. This raises an important question: was this effect discovered accidentally through trial and error, or was it the result of a more systematic approach to materials experimentation? Either possibility points to a level of sophistication that challenges our assumptions about Roman technology. In the ancient Near East, the Baghdad Battery offers another intriguing glimpse into potentially forgotten knowledge. Found near Baghdad, this simple yet suggestive object has sparked ongoing debate about its purpose. While some scholars argue that it may have been used for storing scrolls or performing rituals, others point to its clear resemblance to a galvanic cell. Experimental reconstructions have demonstrated that it can indeed generate a small electric current when filled with an acidic solution. If it was used in this way, it could represent one of the earliest known applications of electrochemistry. Even if its function was not fully understood in theoretical terms, the practical use of such a device would still indicate a level of experimentation and innovation that is often underestimated in ancient cultures. The schist disk of Sabu adds yet another layer to this pattern of unexplained ingenuity. Discovered in a tomb at Saqqara, this object stands out not only for its unusual design but also for the difficulty of its construction. The thin, curved blades carved from a brittle stone suggest a level of control and precision that is hard to reconcile with the tools typically associated with the period. Its resemblance to modern mechanical components has led some to speculate about its function, but no definitive explanation has been accepted. What makes it particularly compelling is that it does not fit neatly into any known category of ancient artifacts. It is neither clearly decorative nor obviously utilitarian. Instead, it exists in a kind of conceptual gray area, inviting interpretation while resisting easy classification. In China, the legacy of the Qin dynasty is preserved in the vast assembly known as the Terracotta Army discovery near Xi'an. While the scale and artistry of the clay soldiers are impressive in their own right, it is the accompanying weapons that reveal a deeper level of technological sophistication. The bronze swords and arrowheads found alongside the figures have remained remarkably well preserved, maintaining their sharpness and structural integrity over more than 2 millennia. This durability is not the result of a single factor but rather a combination of carefully chosen materials and environmental conditions. The high tin content of the bronze increases its hardness and resistance to corrosion, while the specific composition of the surrounding soil creates a stable, protective environment. This suggests that the craftsmen not only understood how to produce high-quality alloys but also how to ensure their longevity through controlled burial conditions. Taken together, these artifacts form a pattern that is difficult to ignore. They point to moments in history where human ingenuity reached levels that seem, at times, disconnected from the broader technological context of their eras. Whether these were isolated achievements, the remnants of more advanced traditions, or simply the result of intense localized experimentation, they challenge the notion that progress has always been linear and cumulative. Instead, they hint at a more complex narrative, one in which knowledge can flourish, disappear, and re-emerge in unexpected ways. The ancient world, far from being a closed chapter, remains an open field of discovery, inviting us to question what we think we know and to explore the possibility that the past still holds secrets capable of reshaping our understanding of human potential.